Hey class. So today's plan is I'm just going to break up the lecture we were going to do on Monday into a couple key components that I'll have you watch before we have our final lecture on Wednesday. And so effectively what we're working on today, although I have the old slide from our presentation on Monday, is we're going to look at compound Lewis structures and then something called formal charge, which we use to look at good Lewis structures, and then finally wrapping up with molecular polarity, and then the topic of our final lab, that molecular models. And so just a reminder, I've extended the due date for chapter 10 homework until the 27th, so the same day as our final. And then for our midterm that we have on Monday, it's just on chapters 8, 6, and 9, and then you can bring that note card. And so on Monday, we were talking about this way that we can determine bonding using Lewis structures. And we said that starts by counting the total number of valence electrons in number 1 here. And that means looking at your s and p orbital electrons. And then if you have a charge on your molecule, you add an electron if it's anionic and you subtract one if it's cationic. Once you've done that, you just draw out a skeleton structure of each of your different atoms. So put them all next to each other. And then we're just going to make single bonds between all of them, as we have on number 3. And then when you're drawing out the skeleton structure, we're typically going to put the least electronegative atom in the center and then put everything else around it. Then our fourth step is that we complete the octet for our outer electrons. So we fill electrons with our most electronegative atoms, place leftover electrons on the middle atom, and then finally, if we don't have an octet for a central atom, we start to form multiple bonds. And then we showed a couple examples. I showed this one of CO2, where we counted up the electrons coming from each of our atoms, carbon and oxygen, 4 from carbon, 6 from oxygen. And then we had a total of 16 electrons. We constructed a skeletal structure by putting carbon in the center, oxygen on either side. Then we formed a single bond. And in forming those single bonds, we used 4 electrons, 2 on this bond and 2 on this bond. And then we added electrons around our electronegative atoms. That would be carbon. So we put 6 electrons around this carbon, 6 electrons around this carbon. So we used 12 new electrons. And at that point, we've used a total of 16 electrons. So we've used all of our electrons. And then what we did is we looked at if our central atom had a full octet. And when we circle each of those atoms, we see that carbon only has 4 electrons, where oxygen each have an octet. And so we showed that we can have multiple bonding where each oxygen donates a set of its lone pairs to carbon. And then the only other way this can happen is if you have carbon having a triple bond to one oxygen and a single bond to another. So these were our 2 options, and we're going to evaluate those 2 options using Lewis structures. And so that was one example we talked through. We then went through this one with cyanide. So counting up the electrons from carbon to nitrogen, 4 from carbon, 5 from nitrogen, and then because we have a -1 charge, that gives us 1 extra electron. That means we have 10 total electrons. We put carbon next to nitrogen. That uses 2 electrons to form the bond. We add electrons around nitrogen. That's 6 electrons going into lone pairs, and meaning that we've used 8 total electrons. We put the final 2 electrons on carbon, and we see that at that point we've used all 10 electrons. And if we look at octets, carbon only has 4, nitrogen has 8. So nitrogen is going to give up 2 sets of lone pairs in order for carbon to get 8 electrons. And that gives us this structure for cyanide right here, where we have a carbon triple bound to a nitrogen. And we have that negative charge outside denoting that we have, like that whole molecule has like this negative charge. It had 1 extra electron. And so what I want you all to do is pause the video here and then construct the Lewis structure for each of the following molecules. So you're going to count out that total number of electrons. You're going to set up your skeleton structures, and then you're going to assign each of your different sets of electrons. And so I'm just going to write which atom is center by putting an arrow above it. So nitrogen, oxygen, sulfur, and phosphorus. So pause the video here, and then we'll come back and construct these. Okay, so welcome back. So for this ammonia, we get 5 electrons from nitrogen. We get 3 electrons from hydrogen. So that gives us 8 total electrons. And so when we construct that, we'll draw nitrogen and we'll draw hydrogens on 3 sides of it. And we can draw single bonds. And in drawing those single bonds, what we've ended up doing is we've used 6 electrons on single bonds. That gives us 2 electrons that we have left out of our 8. So we'll put those 2 electrons onto our nitrogen, since it's the only element that can still take electrons. We use 2 electrons on our nitrogen lone pair. That gives us all 8 electrons that we had, and everything has an octet. If we go to H2O, each H gives us 1 electron. We have 2 of those, so that's 2 from hydrogen. Each oxygen gives us 6. So that's 6 from oxygen. That gives us 8 total electrons. It's going to look pretty similar to our previous example. We put oxygen, we put H's flanking it. We use up 4 electrons on single bonds. And then we're going to put lone pairs around oxygen. We get 1, 2, 3, 4. We have 4 electrons on oxygen lone pair. And then if we look at octets, we see that each hydrogen has a duet, and I'll circle those using our black pen here. Each hydrogen has 2 electrons. And then our oxygen, I'll circle that in purple, owns each of the electrons in the pairs as well as its lone pair, so this has 8 electrons. Then we get down to SO4 2-. Each sulfur, let me thicken that up. Each sulfur gives us 6 electrons. We have a single one of those, so we have 6 electrons from that. Each oxygen gives us 6 electrons. We have 4 of those, so we get 24 electrons from that. And then we get, from our charge, we have a 2- charge, so that gives us 2 electrons. So that gives us a total of 32 valence electrons. So we put our sulfur, we put oxygens around it, we form bonds. That's used up 4 single bonds, uses up 8 electrons. Then we put lone pairs, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And in putting all those lone pairs around those oxygens, that uses up 24 electrons, and that's all 32. So this would be our sulfate anion, and I'll put it in brackets with that 2- to say that it has that charge. And then finally we have PCl3. Each phosphorus gives us 5 electrons. Each chlorine gives us 7. We multiply that by 3. That gives us 21 total electrons. We put our phosphorus, we put chlorines on all 3 sides, and then we can form our bonds. 1, 2, 3. That uses 6 electrons, and so this total is not 21. This is actually 26 total electrons. So we have 26 electrons here. We use 6 to make our bonds, and then we're going to use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 to do lone pairs on chlorine. And what we're left with is 2 electrons, and we can put those onto phosphorus, and we get 2, 4 phosphorus lone pair. And that gives us our structure. So these should be the structures that you came up with. And so that's how we're going to draw up our separate Lewis structures for each of these different ones. So this was just a nice little practice for that. What we're going to talk about in the next video is about something called resonance, and how we can have multiple Lewis structures that define the same type of molecule.